Okay, so in this lesson, we're going to learn about linear pairs and vertical angles, but first, let's do a little review of basic geometry. So this first figure here is called a line. Now, a line goes through at least 2 points and continues in both directions, which is why you see these arrows, and I can name a line in either order. So I can call this line, line AB, or I can call it line BA. Next, we have here, this is called a line segment. You see, I do not have the arrows on both ends. So a line segment, the word segment is piece. So think piece of a line. So a line segment has 2 endpoints. And again, you can name a line segment in any order you want. So I can call this line segment CD or line segment DC. And this third one here is called a ray. A ray has 1 endpoint, goes through at least 1 other point, and continues going in one direction. Now, unlike a line and a line segment, a ray has to be named in the order of endpoint first, then the side that continues second. So I have to name this ray EF like this. All right, so let's talk about naming angles. You see this first angle here made up of ray BA and ray BC. We can name the angle using the 3 letters as long as the vertex B is in the middle. So I can name this angle ABC, or I can name it angle CBA. And when an angle is isolated like this, I could name it just by the vertex, angle B. If I look at the figure here to the right, notice I have multiple lines or rays intersecting each other, and I cannot use the 1-letter naming because all of these angles here have the same vertex, B. So if I said angle B, you really wouldn't know which angle I was talking about. And remember that you have to follow the 3 letters, and sometimes one angle has more than one angle inside of it. For example, here, angle DBF has inside of it, it's made up of DBE and EBF. So that's why we use the 3 letters so that you can follow, from beginning through the vertex to the end to make sure you're looking at the correct angle. And down here, this third figure, you can see that sometimes angles are numbered and you could name them by their number. So this is angle 1, angle 2, angle 3, and angle 4. So 2 important concepts to understand for this lesson are the concept of adjacent angles and congruent angles. First, let's talk about adjacent angles. You may have heard the word adjacent before on the news or in social studies class. You may have heard of adjacent countries. Those are countries that are next to each other, that share a common border. Well, adjacent angles are angles that are next to each other. Adjacent angles share a common vertex and a common ray. So if you see here in this figure, both of these angles, ADB and BDC, both share a common vertex of D, and they share this common ray of DB. So these are adjacent angles. How about congruent angles? Well, the word congruent, when we're talking about angles, congruent angles are angles that have the same measure. So you notice how the measure of angle ABC is 45 degrees. We would write this like this. M angle ABC equals 45 degrees. And we'd say the measure of angle XYZ is also 45 degrees. So the M measure of angle XYZ equals 45 degrees. So they have the same measure. So angle ABC and angle XYZ are congruent. So we can say angle ABC and angle XYZ are congruent, and the way we show congruent is with this symbol. It's an equal sign with this wavy line on top. This is a symbol for congruent. So angle ABC is congruent to angle XYZ. Another important concept to understand is the angle addition postulate. The angle addition postulate says the measure of an angle created by 2 or more individual angles is equal to the sum of the measures of the individual angles. So you can see here angle ADC is made up of angles ADB and angles BDC. And so the measure of this larger angle is the sum of these two smaller angles. So the measure of angle ADC is equal to the measure of angle ADB plus the measure of angle BDC. So angle ADB measures 40 degrees and angle BDC measures 70 degrees. So the measure of angle ADC is 110 degrees. All right, so what is a linear pair? Well, linear pair are two adjacent angles that combine to form a straight angle. We know that a straight angle is a straight line, and the measure of a straight angle is 180 degrees. So if you take a look here, angle ABD combines together with angle DBC. They are adjacent angles, and they combine together to make this straight angle, angle ABC. In some definitions, they'll point out that the non-common rays BA, which is part of angle ABD, and BC, which is part of angle DBC, are opposite each other. So two opposite rays, what do they make? They make a line, a straight line or a straight angle. So what's cool about a linear pair is if you know the measure of one angle, let's say I tell you that angle DBC measures 30 degrees, you can automatically find the measure of the other angle in the linear pair because you know that those two angles have to have a sum of 180 degrees. So I can find the measure of angle ABD by very simply subtracting 30 from 180. So I know that angle ABD has to measure 150 degrees because 150 plus 30 is 180, and these two angles are a linear pair. Now, in a diagram like one down here in the bottom, when you have two lines intersecting, you have many combinations of linear pairs because any two angles that fall together on a straight line, that's a linear pair. For example here, angles 1 and 2 here combine to make a linear pair. But how about here, angles 2 and 3? They also fall along this line, so they also make a straight line and they are a linear pair. Well, then how about angles 3 and 4? Angles 3 and 4 also fall along the bottom of the same line as 1 and 2, so they make a linear pair. They have to equal 180 degrees. And finally, angles 1 and 4 also fall on a straight line, so together they make a linear pair as well. All right, so now vertical angles. What are vertical angles? Vertical angles are two non-adjacent angles formed by two intersecting lines. Think of them as opposite angles. So if we look here, we have four angles, angles 1, 2, 3, and 4, formed by these two intersecting lines. Now, 1 and 2 are not vertical. Why? Because they're adjacent. They have this common ray here. So how about 1 and 3? They do not have any common rays, and they are opposite each other. So angles 1 and angle 3 are vertical. And how about angle 4 and angle 2? Angle 4 and angle 2 are vertical. So whenever you have two intersecting lines, you will end up with two pairs of vertical angles. So what makes vertical angles special? Well, let me show you. Let's say I tell you that angle 1 measures 140 degrees. So then what does angle 2 measure? We just learned that angle 1 and angle 2 are called a linear pair because they combine to form this straight angle right here. So therefore, I know that angle 1 and angle 2 have to combine to equal 180. So if angle 1 is 140 degrees, what's the measure of angle 2? Well, 180 minus 140 is 40. So let's move on. How about angle 3? What's the measure of angle 3? Well, again, thinking about linear pairs, Angle 2 and angle 3 are both linear pairs. They make this straight angle here. So if angle 2 is 40 degrees, then angle 3 is the rest of the 180 degrees, which we already know is 140 degrees. And again, since angle 3 and angle 4 are a linear pair, if angle 3 is 140 degrees, then angle 4 has to be the rest of the 180 degrees, which makes it 40 degrees. Now take a look at what happened with our vertical angles. Angles 1 and angle 3 both measure 140 degrees. And angles 2 and angle 4 both measure 40 degrees. So what makes vertical angles special is that vertical angles are congruent. Remember, this is the symbol for congruent. That means they have the same measure. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. So one of the things you'll be doing a lot in geometry are proofs. And that's to prove something is mathematically true by taking a look at the facts or the evidence and providing your reasons for those things to be true. So we're going to take a look here at a 2-column proof to prove that if two angles are vertical, they are also congruent. This is very similar to the example I just showed you, but we're going to do this giving the official statements and reasons. So it says given that angle 1 and angle 3 are vertical. When something is given, they're giving you that information to start off with. Prove that angle 1 and 3 are also congruent to each other. So here we go. Statement number 1, angle 1 and angle 3 are vertical. What is our reason? Why do we know that? Because it was given. They just told that to us right in the beginning. Statement number 2, angle 1 and angle 2 are a linear pair. So let's take a look here. Look at our diagram. We see that angle 1 and angle 2 are adjacent and they combine to make this straight angle. So we know that they're a linear pair. And so what is our reason? Definition of linear pair. So since angle 1 and angle 2 are a linear pair, statement number 3, that means that the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. Because if they are a linear pair, that means that when you add them together, it has to give you 180 degrees. Now, what is our reason that involves adding two smaller angles together to give you the measure of a larger angle? Remember, that is called the angle addition postulate. Statement number 4. Angle number 2 and angle 3 are a linear pair. We look at them, and angle 2 and angle 3, they're adjacent and they combine to make this straight angle here. So how do we know that they're a linear pair? Definition of linear pair. And if angle 2 and angle 3 are linear pairs, then we know that the measure of angle 2 plus the measure of angle 3 has to once again equal 180 degrees. And what is our reason for that? It is the angle addition postulate. So that leads us to statement number 6. If the measure of angle 1 plus the measure of angle 2 is 180 degrees, and the measure of angle 2 plus the measure of angle 3 is 180 degrees, that means that the sum of the measure of angle 1 and the measure of angle 2 is equal to the sum of the measure of angle 2 and the measure of angle 3. They're the same. Now, what reason do we have for that? Well, we have the substitution property. That basically means we can substitute angle 1 plus angle 2 with angle 2 plus angle 3 because they both equal the same thing. So we can substitute them. Now, what do both of these have the same? If you were solving this equation, what could you get rid of? Well, you could subtract angle 2 from both sides. And what does that leave you with? That leaves you with the measure of angle 1 is equal to the measure of angle 3. and that is the subtraction property of equality, which we learned in algebra. I'm just going to write subtraction property here. And so if the measure of angle 1 is equal to the measure of angle 3, that means we know that the angle 1 is congruent to angle 3. And that is the definition of congruence. Right, so the last part of this lesson is to use the concept of linear pairs and vertical angles to find angle measures algebraically. So if we look at this first example here, we have this angle ABC measures 5x plus 5 degrees, and angle CBD measures 2x degrees. And what we want to do is we want to find the actual numerical measures of these angles. So how do we do that? Well, we know that angle ABC and angle CBD are a linear pair. They make the straight angle, the straight line, ABD. So we know that the sum of these two angles has to be 180 degrees. So we can set this up as an equation. 5x plus 5 plus 2x must equal 180 degrees. And so now we combine like terms. We have 5x plus 2x. That's 7x plus 5 equals 180 degrees. Then we're going to subtract 5 from both sides. And we get 7x equals 175. And then we divide both sides by 7. And we get x equals 25. So we know that x equals 25, right? So if ABC measures 5x plus 5, we have here 5 times 25 plus 5. Well, 5 times 25 is 125, and 125 plus 5 is 130. So we know angle ABC, we know that the measure of angle ABC is 130 degrees. And so how about CBD? That means CBD must be 50 degrees. Well, what's 2 times 25? And that is 50 degrees. So the measure of angle CBD is equal to 50 degrees. So on this final example here, we need to find the measure of angle FGJ and the measure of angle HGI. So what do we know? Well, we know that they are vertical angles, which means that they are congruent. They have the same measure. So we can set this up as an equation with variables on both sides. So 3x minus 10 is equal to 2x plus 10. So first thing we want to do is eliminate the variable of lesser value. So we're going to subtract 2x from both sides. And this gives us here x minus 10 equals 10. And then finally add 10 to both sides here. And we get x equals 20. So if x equals 20, 3 times 20 is 60, and 60 minus 10 is 50 degrees. And 2 times 20 is 40, plus 10 is also 50 degrees.